I have a question.
Yes.
Is that okay? They tagged me to come in here and ask you because you said you wanted to just ask me about my question. So if you're familiar with Airy's failure, I just want to know if you have an answer as to why the aberration angle in Airy's telescope didn't change when it was filled with water.
Yes, because so the Klinker-Fuse's undulating theory of light predicted that as the Earth moves through the ether, the luminiferous ether, that the light would slow down, and that it would then hit the side of the telescope. And so when that did not happen, then they were kind of confused because they were looking. They thought the undulating theory was correct. And so it confused them that it didn't work. So what happens is the light slows down in an external reference frame, but within its own reference frame, it's still going the speed of light.
So what about the emission theory, though? Because isn't that what we use now?
Yeah, it's essentially the emission theory. Yep.
But in the emission theory, the light gets slowed down by the water. So it's still a slower velocity.
Yeah. So the emission theory. The emission
ratio of the velocities.
Yep. So the emission theory is essentially, I said essentially because that's within our reference frame. But general relativity, special relativity is the better understanding of it. So within special relativity, the light slows down in the reference frame of the water from an external reference frame. But within the reference frame of the water, which is the only place that the light is moving, it's still moving at the speed of light. So inside the water, it's moving at c.
Wait. In the lab, the telescope and the water and the Earth all move the exact same. They're all a part of the lab frame.
But the light travels at the speed of light in water when it's in the water. And it's a three-dimensional thing, not a one-dimensional thing.
Klinker-Fuse, well, he believed in a static ether, but that's kind of like a straw man anyway, because the description that they believed in that would explain it with ether was one in which the ether caused the light to move, because you can't tell just looking at the telescope and the light by itself if it's Earth or if it's the starlight that's moving. So they said, okay, let's put water in it, because the formula for the aberration angle is tangent theta equals Earth velocity over light inside the telescope velocity. So once we put water in it, that second variable, the light inside the telescope velocity, will be a smaller number, so the tangent theta angle should be a bigger number. It doesn't matter which model you're using, because that's the formula in every model. That's the formula we even use today. And we know that light slows down in water.
Yeah, like I said, it's still moving at the speed of light in the water, but you apply special relativity, and right, they're different reference frames. So,
but there's nothing moving at relativistic speeds. This Earth's only moving like 66,000 miles an hour or 30 kilometers a second. It's nowhere near the 10% or more speed of light needed to apply relativity. Any relativistic calculation is going to be equivalent to the small angle approximation, which is equivalent to the tangent theta angle equation at these velocities.
Yeah. So yeah, you're just going on pure emission theory and not taking into account special relativity. It's okay. But that's not obviously what works. Since the motion of the Earth has been confirmed externally to that previously. So this one thing contradicted the emission theory, but it didn't make any of them say, oh, I wonder if the Earth is not moving, because there's several other things that confirm that the Earth is moving. So
if it wasn't in the frame of the water, the light doesn't change speed. If you say it's still C in the water, at the two ends of the water, there's a speed change. So in the water, it would be C plus or minus V, because we still know that the light has got a a drift, a sideways drift on it, because that's the only way it reaches the eyepiece center. That's why the tilt has to be applied. So if in the frame of the water it's C plus or minus V,
but
that still breaks relativity.
No, it doesn't. Is the water also moving laterally?
Everything on the Earth system in the lab is moving laterally if Earth's moving.
There you go.
But if it is, then it moves out from under the starlight, and that's why the telescope would have to be tilted. So when you add water, the tilt has to change because the velocity of light is different in the lab frame.
Given how the length of the telescope, how many nanoseconds will the light be passing through the water?
Well, that's not really the issue. The emissive theory without special relativity is, doesn't explain it. And so he's right. He's right on that the emission theory. So if you read the beginning of especially if you read the beginning of Michelson Morley, it talks about the emission theory of light, which kind of goes back to Newton. It's popularized back then that it was particles or corpuscles of energy, and they were emitted. Thus the emissive theory. Yeah. So
we still use that theory today.
Also, let's not forget now that we have instruments, and even in the amateur days in the late 19th century, that you can measure the stellar aberration, which is precisely the shifting of positions because of Earth's motion around the sun.
Yeah.
But there's only two variables in the formula. That's what I'm trying to get at. The formula is super simple. The tangent theta angle equals Earth velocity over light in the telescope velocity. So if you change either of those two variables, the tangent theta angle has to change. You can't have the same tangent theta angle if you change the two input variables.
Yeah, and where you missed the part where you need to apply special relativity.
Can you provide any links to any resources that show a calculation that fixes it in relativity with special relativity? Because the change, if we measure it in the lab frame, that's where the tangent theta angle approximation is used. They don't calculate it in the, in some relativistic coordinate system where you apply, where you take the frame of the water and say C is C in the water. We know dynamically that the water slows the light down, right? Because if you go to the frame of the water and say the speed of light is C in the water, then as soon as the light leaves the water, it's speeding up and it's exceeding C. So it would exceed the speed of light in that frame if you force light speed to be C in the water. As soon as it leaves the water, it speeds up past C. You can't have that.
Yeah, and like I said, if you want, I can provide them. I don't have them handy though. Like I said, and to one more time. One more time to reiterate that the water is also moving laterally. So okay.
There's a second problem with it too. Because other than violating special relativity by forcing light speed to be C, there's also Snell's law, which states that if light hits a refracting medium such as water at a non-perpendicular angle, it will introduce an additional refraction angle into the system. And so if the light travels vertically, it won't do that. But if the light comes in at an angle, it will do that. And if the telescope is tilted and the light's coming in vertically, when you add water, it would have to change the angle from that reason as well. So the fact that Snell's law being applied in the system actually doesn't create a real physical refraction angle in the water means that the light's already coming in at that angle as well. And the only way it can already be coming in at that angle is if Earth is stationary.
Are you talking about the interface between the lens and the water? Or the interface between the lens and the air?
The lens, when the light enters the water, right? Because you have a stream of light coming, what's assumed to be vertically, right? If it's just starlight streaming towards the telescope. But if Earth's moving, you then have to tilt it. Well, when you tilt it, it's coming in vertically, and it's a non-parallel or non-perpendicular surface now because the telescope's tilted.
But when you tilt it, you've now made it straight in relationship to it, to the light path.
No, it's already straight. The star's at the zenith.
Well, the star is Sigma, not
It's a
Sigma.
zenith telescope. It's a zenith mount.
No, it wasn't. It wasn't straight up. It was at an angle, right? But it was I forgot the name of the star.
Well, it
But yeah, it
a
wasn't.
zenith mount telescope. They use 2 spirit levels to level it off to make sure it's at zenith, pointing to the true position of the star, as according to the almanac. And then they look in it, and then based on optics, they see what the arc-second correction is needed to center it, and then it becomes tilted.
Okay.
But then when they add the water, since it's tilted, now there should be refraction introduced from Snell's law as well. So there's actually 2 sources of additional angle correction that should be input, but none was needed.
Did you calculate the predicted change in angle?
Yeah, they said they believed it would be close to 30. I mean, if you just take the 20.2 or whatever it is and do 4/3, because the speed of light and water is 3/4 that of C, then that means the angle change would be 4/3 of the standard angle. So since the standard angle is just over 20 arc seconds, it bumps it up to like 28 roughly, 27, 28, close to 30. But it didn't change. So in order to analyze it, you can if you make the Earth stationary, right, and you add velocity to the water to change it to catch up to that extra angle, you'd still need a correction angle. The only way that you can make it work is if you treat the system in which you're measuring it in as stationary, and you treat the light as already coming in at that angle. So you have to use a geocentric coordinate system in order to make the physical observation as was made work.
All right. Well, sorry, I was handed an orange cat. Thank you.
That's what that noise was.
Yes, that was that cat named Turtle. He was cranky because the dog is in here, and now the dog's trapped in here. Anyway, the water is moving, and the key part of it is that the water is moving along with it. But anyway, if you want, I can send you some additional resources, or we can set up a time to have a conversation.
Yeah, please send the papers. I mean, because you can't.
But like I said, I don't have them handy. So I don't have them even in my notes.
If you say the water's moving with it, though, you can't analyze the Earth as stationary for the transformation with respect to fixed stars and have an Earth that's not fixed. You're making both velocities. You're putting both velocities under transformation, and that violates Lorentz symmetry, even under a relativistic paradigm.
All right, so what is your position? Are you geocentric glober?
Concave Earth doesn't have this problem.
Yeah, so Airy's failure proves geocentrism. It has nothing to do with shape.
But you didn't answer the question. Are you a geocentric glober?
I'm here to discuss shape. I'm here to discuss motion.
Okay.
Right. So I'm
I'm
a
here.
Bible believer.
I'm here to discuss shape.
But you can't have heliocentrism either. So
Robert Sungenis aggressively disagrees with you.
Well, I think that the Bible is always historically taught geocentrism. It always was taught geocentrism. People didn't stop believing in it until the modern era. Even the church opposed it when it first came out as a heresy, and they were right because the Bible clearly teaches it. They had to adopt modern post hoc explanations and eisegesis of the text in order to insert heliocentrism upon it. But it clearly teaches geocentrism, and that's what the experiments show as well. The first historical famous one being Airy's failure.
Unfortunately, the movement of the Earth is
I'd appreciate the papers.
Yeah. Now, Bob.
Unfortunately, as Mike said, the motion of the Earth has already been established by other means.
Yeah, previously.
By what experiments?
It's not subject to. That's not the subject of the experiment.
Yeah, I can list them though. James Bradley in 1727. Aberration, which of course is this topic, right? So then you asked me. All right, I won't list them if you don't want me to.
No, go ahead.
Okay. Of course, parallax from Bessel in 1836, I think. You've got Vogel and Schneier.
That's not mutually exclusive. It works equivalently in a geocentric paradigm. Parallax.
How about you let him finish?
Okay, so obviously he doesn't want me to. He doesn't want me to finish. Thank you. We'll talk to you later, but not now, since I don't get to finish.
All right. God bless you, man.
Don't want to hear it.
I
don't
just
care.
didn't want the,
Don't care. Don't care. When you talk like that, I don't want to hear about your God. I'm not impressed with your God.